Hey everyone, welcome to my YouTube channel. Here I share videos on the latest tech and helpful tips. If you enjoy this kind of content, make sure to subscribe. Now let's get started.
You want to boot pop _OS in UEFI mode while keeping secure boot enabled, a goal often seen as challenging because pop _OS doesn't natively ship with the signed boot components that many other distributions, like Ubuntu or Fedora, provide out of the box. Secure boot is a critical UEFI firmware feature designed to prevent malicious software from loading during the boot process, ensuring that only trusted, signed operating system loaders and drivers are executed. Disabling it can potentially expose your system to rootkits and other low-level threats. So finding a way to work with it is ideal for security-conscious users. The core problem lies in the fact that pop _OS, by default, uses systemd and its kernels are not signed with a certificate that is universally trusted by UEFI Firmware Secure Boot Database. To achieve our goal, we need to make your UEFI firmware trust the pop _OS bootloader and kernel. This involves a process of generating your own cryptographic keys, signing the necessary pop _OS boot components with these keys, and then enrolling these custom keys into your motherboard's UEFI firmware. While this sounds complex, breaking it down makes it manageable. The first step involves understanding the key hierarchy within Secure Boot. The platform key, PK, the key exchange key, KEK, and the signature database, DB. You will generate a set of these keys. Tools like efitools or sbctl can assist in this process, allowing you to create your own platform key, which establishes trust for the firmware, a key exchange key, which allows operating systems to register their own keys, and finally, database keys, DB, which are used to sign individual bootloaders and kernels. Once these keys are generated, you'll need to enroll them into your UEFI firmware. This typically involves booting into your motherboard's UEFI settings, navigating to the Secure Boot section, and finding options to enroll or manage keys. You will replace or add your generated PK, KEK, and DB keys, effectively telling your system to trust anything signed by these new keys. This is a crucial step as it customizes your system's trust chain. With your custom keys enrolled, the next phase is to prepare your pop _OS installation. You'll need to sign the pop _OS kernel and the systemd bootloader with your newly created DB key. This step is often performed after pop _OS is installed, or you might need to boot the pop _OS installer with Secure Boot temporarily disabled to get the initial installation done, then re-enable Secure Boot and perform the signing steps. However, for a truly without disabling Secure Boot approach from the start, you would prepare a custom pop _OS ISO with signed components, which is significantly more involved. A more practical approach for most users is to install pop _OS normally with Secure Boot disabled, then immediately after installation, generate and enroll your keys, and sign the installed pop _OS kernel and bootloader. This ensures that on subsequent boots with Secure Boot re-enabled, your system will recognize and trust the pop _OS components. You'll use tools like sbsign to sign the kernel image and any associated EFI binaries. Remember that every time the kernel is updated, you may need to re-sign it or set up automated scripts to handle this. This method provides the highest level of control and security, allowing pop _OS to boot successfully while maintaining the integrity checks provided by Secure Boot. Thank you for watching, and please remember to like and subscribe for more technical guides and tips.